Hi everyone, let's discuss about design of sequence detector. To illustrate the design of clocked MEALY sequential circuit, we will design a sequential circuit or sequential detector. The circuit will examine a strings of zeros and ones applied to the X input and generate an output Z is equal to 1 only when a prescribed input sequence occurs. It will be assumed that the input X can only changes between clock pulses. Especially, we will design the circuit so that it will detect the particular sequence. Let's discuss about the one sequence called 101. Suppose we are giving input called X and we are taking output from Z and we are doing such a circuit which can detect the sequence 101. So, if you give first input 0, obviously Z is 0 because it is not a sequence. Then if you give one more number 0, again it is not a sequence, so 0. If you give 1, so it will take last 3 bits, so 001. 001 is not a sequence, so it will become again 0 here. If you give one more number something called 0, it will take last two number like 010 is second part. So 010 is not a sequence, so it is again 0. If you give again 1 here, so it becomes 101. If it is 101, it is sequence detected, so it becomes 1. This way we can get the particular sequence detected in giving the X input. So here we have to give clock pulse. Each clock pulse it is varying. Let's do the process of this one, how we can do this sequence detection using step by step. First step, our aim is to what exactly the sequence is detected. So 101 means we will go with the first step S0. So in the S0 step, usually whichever the first number is there, complement of that, or we can call as a reset number. So that number is actually 0 here. So S0 state you are taking as a complement of first bit number 0. Next state we can take S1. So this state is first bit of the given pattern. So first bit of the given pattern here 1. So we are taking S1 state is 1. Then we are moving to the S2 state. It is nothing but first two number of the sequence. In this case, the sequence is 101, first 2 bit is 10, so 10 is the S2 state. From this state, we can know that these are the previous state. From this, we can select the input value X. What happens in the S0 state? There is a two possibility. Either we can get 0 or 1. Similar way, S1 1 also we can get 0 1. Similar way, S2 also we can get 0 1. Now, what is the next state for this we can discuss. Check it out here. The first state part is 0 0. 0 0 is not there in any state. If two number is not there, go for the single number. Single number is 0, so 0 state is S0, so it is going S0 when X is 0. When X is 1, it becomes 0 1. 0 1 not there in any state, so it will check only last number 1. So 1 is there in state S1, so it is going to the S1 state. Similar way, it will check for S1 part next 10. So 10 is not 10 is there in the S2 state, so it is taking S2 here. 1 1 not there in any state, so it will leave the second bit and come to the last bit only 1. 1 is there in S1 state, so it will be there in S1 only. Similar way, go for S2. It is 100, so 3 number of state is not there anywhere, so leave the last one 00. 00 state also we don't have, so last state is 0. So 0 state is there in S0, so go with that. Similar way, 101 is not there in any state, 01 not there in any state, so 1 is there in S1, so it is going to the S1 state. Now, what is the Z value for this one? So if you take Z value, we know that only the sequence 101 comes, it is high. So 101 means this is 10, here 1. So in this state only Z is high. All the other condition Z is 0 only. So we can do the like this table to the step 1. This is for the state diagram, we can use it. Now here we can fill the values of S0, S1 to assuming that in the step 2. So step 2 we can assume the S0 value 2-bit numbers, so 0 0, because here 3 state we have. 3 state we can easily do it in 2-bit numbers. So first is 0 0, then S1 we can take as a 0 1 and S2 is 1 0. So this state is simply universal to all state. So start from 0 0, 0 1, 1 0, and 1 state is not there. So we can take this state as a don't care. So we can fill with those numbers in this state. So previous state we can call as a flip flop. So we can call this one as a one is QB, another one is QA. So the QB and QA we have the S0 means 0 0 and S1 means 0 1, S2 means 1 0 and S3 state is not there. So 1 1 is don't care, actually we have to take. So what is the X value for this one? Here for 0 0 I have 2 possible, 0 1, for 0 1 again 2 possible, 0 1, in 1 0 again 2 possibility, 0 1, 1 1 again 2 possibility, 0 1. So what is the next state here? So S0 is nothing but 0 0. So here 0 0 we will get. Next state we will call as a QB plus and QA plus. So 0 0 is the state of S0. So we have taken. Second one here S1. S1 is nothing but 0 1. So go with 0 1. Similar way, next S2. S2 is 1 0. So 1 0 here. Next S1 is 0 1, so 0 1 here. Then S0 again 0 0, so here 0 0, and then we have S1 last one. So S1 is 0 1, so 0 1. This is how we can fill with this next state to these values. And the last state we don't have, so simply fill with the don't care. This is how step 2 is formed with the QA and QB plus. Next we can take any flip-flop to the draw this one. Here for easy purpose we will do the D flip-flop because DB and QB plus remains same and DA QA remains same. If you take JK or SR flip-flop, you have to go with the excitation table. According to that you have to do. So I will copy DB as a QB. So 0 0, 1 0 and 0 0 and don't care, don't care. Similar way DA. So 0 1, 0 1, 0 1 and don't care, don't care. So this is how we have completed particular step 2. So step 2 is nothing but we are writing as a stable diagram. In this what is the previous state and what is the input given. For that input what I will get the next state. From the step 1 whatever table done, only we have to put S0, S1, S2 value to here. So in the step 3 we will go with the very important procedure, that is how we are done in the counter, same as we have to do K-map for those one. So I will do K-map for DB and DA. First I will take for DB, for DB. So here how many bit we have? Actually the input portion is QB, QA, X. So we have 3 input here. So go with the 3 input case. We will draw the diagram according to the 3-bit K-map and make it as a one side as a QB. So another side QA and X. So the QB is we will take 0 1, QAX we can change it 0 0, 0 1, 1 1, 1 0. Now check it what DB here. DB is 1 at the condition 0 1 0. So 0 1 0 is here. So this is 1. And next case it is don't care in the 1 1 condition. So 1 1 0. So 1 1 0 is here and 1 1 1 is here. These two are don't care conditions. So we can do the grouping of something like this, the last one X, and here the 10 present of QAX, so we can write as it is QAX bar, and QB present both 0 1, so it cancel out, so we will get DB is equal to QA into X bar. Similar way we will go for the next one called for DA. So for DA also we can copy down the previous state what we had done. So in this state again the 3 variable, so first we can take as it is previous QB, then QA and X. Here as it is 0 1, so fill with the numbers 0 0 0 1 1 1 1 0. So in the DA, check it out where it is 1, the 1 at the condition of 0 0 1. So 0 0 1 means 0 0 1, so this is the high. Then it is high in the 0 1 1, so 0 1 1, so this is the high condition. Then it is high at 1 0 1, so 1 0 1 it is high, and don't care with 1 1 0, so 1 1 0 it is don't care, and 1 1 1 also it is don't care. So we can do the grouping of these 4 together, and from this grouping we can say that QB is cancel out, and here 0 1 purpose QA cancel out, so DA is equal to X. This is the equation what we got from the particular sequence detector. From this diagram we can say that this is the portion for 2 flip-flop DA and DB, how can we design. Also we have to check with the one more stuff called as a Z. In step 2 we have to make Z here. Z is as it is, you have to fill 0 0 0, all these condition it is 0, and last condition it is 1, and other 2 again it is don't care. So if you go for the Z, what we will get, try for the K-map, again the same stuff. So if you go with something like this, so here the same copy down QB and QA and X, so 0 0 0 1 1 1 1 0, and here it is 0 1, so Z is high at, we know that the condition 1 0 1, so it is high at 1 0 1 1 0 1 high, and all other condition 1 1 0 and 1 1 1 it is don't care. So we can take as a this portions. So here QB is high, take QB, and we can make that the 1 is common here, so it is QB into X. So these are the formula for the DA, DB and Z. Now in the step 4, your work is to draw the diagram according to the whatever equation we got. So the each equation we have 2 flip-flop here. So draw first 2 flip-flop. First one is nothing but DA, and we have QA. Similarly, we have another one flip-flop called DB, and we have QB. So here the clock anyway we have, and we can take clock here. We can take as a synchronous, so clock is common here. This is the universal diagram of DA, DB and clock. Now according to our diagram you have to write. So here DB is equal to QA into X bar. So we have to take one more input called X here. So take it X here, and we have to make as a X bar. So make it X bar and connect it to the DB. So X here and make it X bar, and another one is QA. So take QA and make it as a AND gate and connect it to the DB, because QA into X bar is AND gate. Similar way, DA is nothing but X. Simply give X to the DA. So no gates, nothing required. And finally I require ZB or Z. Z is nothing but QB into X. Take X as it is and QB, and these are AND gate, and make AND gate and connect it to this one. This is nothing but Z value. So this is the whatever here we have written block diagram sequential detector. This is the sequential detector. We have input like X, we have input like Z, and we have this is nothing but clock pulse. In between whatever circuit we drawn according to these procedures. In the final step, we can write the state diagram of the sequence detector. Here state diagram, we can do 2 type of state diagram. One is called MEALY, another one is called Moris. Here we are discuss about how we can do the MEALY state diagram. So we have to go for step 1, and step 1 procedure whatever we are done, according to that we can do the state diagram. First go to the S0. So S0 state is there. S0 state, there is a two condition, x 0 and 1. So take when 0, it is going to the S0 only. So we can do something like this. This is the 0 state and output Z also 0. So this is 0 0. So we have to write something like x bar Z value. So x value is 0 here and Z is 0. When S0 state x is 0, we are taking as a S0. So it is a self state part. So it is going into the self. Next go to the S0 0 when x is 1. When x is 1, it is going to the S1. So we can write one more part called S1. In this, when it is S0 is 1, it is going. And what about Z value here? It is 0 only. So it is 1 bar 0. So come to the S1 state. When it is 0, it is going to the S2. So take one more state called S2. So when it is S1 is 0 state, it is going to the S2. So make it as a 0 here. And Z portion, anyway it is 0. So 0 bar 0. Similar way, S1 one more option is there, x is 1. When x is 1, it is a self. So S1 only. So we can take something like that, the self 1, and when input is 1 and Z is 0 only, because in this state also Z is not recognized the sequence. So the final step we will go for the S2. When S2 x is 0, it is going for the S0. So it will check something like that. When it is 0, it is going for the S0 and output also 0. So it is 0 bar 0. Another one state possible, that is 1. It is going for the S1. So when it is 1, it is going for the S1. The thing is Z is 1 because the sequence is detected. See here 1, 0 and 1. So 101 is our sequence. So it is detected. So output is 1. So this diagram is known as state diagram or MEALY state diagram. Here I have written in a last step 5. So you can write after the step 1 also possible. In between anywhere you can write this state diagram. Next we will discuss about sequence detector using Moris state diagram. Previously whatever we have done using MEALY diagram, in there we are done actually 5 steps and state diagram, and then we are made as a step 1 state table, step 2 we are converted into the numbers, then we are done K-map and state diagram and also diagram. So the same procedure we have to do for the sequence detector using Moris also. The thing is, small changes in the step 1, the particular portion in the MEALY we are done as a S0, S1, S2, total 3 state we have taken. So instead of taking 3 state here, in the Moris we are taking 4 state. How we have to take 4 state? As usual, S0 is equal to 0 only and S1 is equal to 1 and then S2 is equal to 1 0. This is the common state diagram what we have taken in the MEALY. One more state diagram we have to take, that is S3. So S0 we have taken for first bit whatever opposite, S1 is a first bit, S2 is a first and second bit, S3 is a 3 bit. So 101 is the S3 state. So the difference between Moris and MEALY, it is Moris having the total 4 state. We have to consider all the 3 patterns together, that is 1 state in the Moris. So when you go with this one, you can take this one as the previous state, and then as usual we will go with the x values. So if you take as x values, again we have 2 possibilities, 0 1, here S1 also 0 1, S2 also 0 1 and S3 also 0 1. So we will discuss about the how it is next state going on. Actually we can copy down the next state as usual how we have in the step 1, S0 S1, when S0 0 it is S0, S0 0 it is S1. This is remains same because here we are not changing any state. So the 0 0 not there. So 0 is S0. So it is going S0 only. Next it will discuss about 0 1. the 0 1 not there, 1 is S1, so it is S1 only. Similarly in the S1, when it is 0, it become 1 0, so it is S2, and 1 1 state is not there, so it is going for 1 and S1. So first two state is similar to the melee. Now in Moris, what difference is, when you going for 1 0 0, again 1 0 0 is not there, so it will go for the 0 0, and 0 0 also not there, so it will go for the 0 and state is S0. Next it will move on the 1 0 1. 1 0 1 we have in the S3, so this state become S3. Again we will go with the S3 1 0 1 0, 4 number of state not there, so go for 0 1 0. 0 1 0 is not there, so 1 0 is there in S2, so it is S2 state. Similar way 1 1 is 1 0 1 1, 1 0 1 1, 4 state not there, so 0 1 1, 0 1 1 also not there in any state, so 1 1 1 1 also not there. Last one is 1 is there in S1, so this is S1. And at what condition we have to get Z is 1, that we have to check, and we are getting 1 0 1, that means this S3 portion only 1. All the other condition, this is 0 only. We have to take Z when it is 1, so all the condition of S2, S1 and S0, it is 0 only, and only S3, it is 1 0 1 condition, so it become high. So we have to make something like S3 state is 1, other all the state is 0 for the Z0. Similar way we can go for the step 2. Step 2 is same as we are discussed in the previous state. Simply we have to convert S0 S1 to the somewhere. So take S0 as usual, previously 0 0, S1 is 0 1, and S2 is 1 0, and last one S3 is 1 1. So if you get this state, we can convert into the that. So previous state we will call as a QB and QA. So the first state we can call as a, that is 0 0, and then 0 1, then 1 0, then 1 1. So the X is input, two possibility 0 1, 0 1, 0 1 and 0 1, and next state is what we have to write. So we can write QB plus and QA plus. So check with the state in the previous part. So here S0 is there, first one S0 is 0 0, so copy down 0 0. S1 is nothing but 0 1 from this, so 0 1. Next it is S2, S2 is 1 0, and S1 is 0 1, and then these two is finished. Then we are going for the S2 portion. So S0 is again 0 0, and we have something like S3 is 1 1, so this state become 1 1. Then last state it is S2 is nothing but 1 0, and S1 is nothing but 0 1. So this is what we got as a state diagram to the state table. From last we can take Z, the final two are 1 1, all the other 0. So simply fill 0 to the other state. If you want to write the state diagram of Moris, you have to consider two things here. The one thing, we have to make the similar way what we have done in melee machine up until the input sequence 1 0 has occurred, except that 0 output is associated with states S0, S1 and S2, and we have to take as a all the three state. So first we can do the step 3 state diagram, how it look like. So first take as a S0. So S0 state is here. If you take, when it is 0, it is going to the S0, so 0 S0 only. When you taking S0 state, we are making 0, and previously in the melees we are taken something like, if you look at the melee state portion, here we are taken S0 and 1 bar 0, that means this is the input value X and this is the output value Z we are taken. Instead of this, here we are only taking X value, that is nothing but 0, and Z value we are taken in the circle only, and that is Z is 0, so make it 0. Similar way we can take for the S1 also. So S1 will take somewhere here. So S1 output is 0, so make it 0. Okay, and then the state of S0 is 1, it is going to S1. So when it is 1, it is S1. Only write input and output write inside the circle 1. So in the S1 state, when 1 it is 0, it is going to S2. So write one more portion called S2, and S2 is output is 0, write 0. So S1 is when 0 it is going S2, so make it 0 S2, and when 1 it is going to the S3. So write S3 here. So S3 state is 1 because this output is 1 in all this Z portion. So when S2 is 0, S2 is 1, it is S3. So make it 1 S3. Similar way, in the S3, it is 0 going to the S2. So make it 0, it is going to S2. When it is 1, it is going to S1. So we can convert like this. When it is 1, it is S1. Similar way we can convert it, this portion. Here one more topic we left, that is S2 is when 0, it is going S0. So we can take something like 0, it is S0. So these are the final diagram of the mode. This is the previously melee, and this is how we are written only 3 state and like that. This has 4 state and output only outside, output inside and input in the outside. This is how block diagram look like the Moris. And other portions what we have to discuss is how to do K-map and these portions that is similar to the previous version. So we can do the K-map for the same what we are done previous portions. So here how we are done for dB. So wherever don't care, we have to make as a 1 over there. So we can do the grouping according to that. So go for the step 4 here. In the step 4, we have to make as a for dB wherever same copy down previous operations. So it look like something like this. So in this we have QB and QAX. I am not filling all the numbers. So 1, wherever don't care, we are taking that number as a 1. So here in the up to this case it is same, where changes we have to do it. So check it out in the dB. dB is nothing but QB plus, already we know that. So QB plus 1 net 0 1 0. So this is 0, this is 1, 0 0 0 1 1 1 1 0. So it is 1 net 0 1 0. So 0 1 0 1 already I have written, and then 0 1 1 0 not required. Next 1 0 1 is 1. So 1 0 1 is 1. Then it is 1 1 0 it is 1. 1 1 0 it is 1. This is the word diagram we got. When you are doing K-map for dB, you will get equation the previous as in the Miles we are done. Whatever the QA and X bar, same we got here, and the extra thing we got 1 in the this position. So this equation if you take, it is because of 0 not present here, only 1 present here, so it is QB, and 0 1 means QA bar and X. So your dB become QB into QA bar X plus QA into X bar. Similar way, if you go for DA, it is as usual as previous DA. There is no change in the previous and this. So you will get DA is equal to X in the both the condition. If you go for the last one ZDA, K-map is not required because it is 1 at the position where QB and QA both are 1 1. So when both are 1 1, X is 0 1, it is a don't care because it's 0 also it will comes and 1 also. So it is not dependent on X. So we will take directly Z is equal to QB into QA. Similar way, from this circuit diagram, we can build the particular logic circuit diagram from that. Similar way, DA, DB write it, and according to equation, give the gates to that one, you can do the stuff. So this is how sequence detector using Moris we can be done. Next one example we will take for MEALY state diagram. A sequential circuit has X input and Z output. This is as same as previous. The circuit examines group of 4 consecutive input and produce an output Z is equal to 1. So it has previously we have taken 3 consecutive, now it is 4 consecutive, okay, and output is Z1 if input is 0 1 0 1. So 0 1 0 1 is one sequence, other one is 1 0 0 1 occurs. The circuit reset after every 4 input. So every 4 input we have to go for the reset state and once again we have to start. Previously we are going with continuous part, but here we have to go with the reset. Find MEALY state graph. So how can we do this one? So this is as usual the diagram you can take. So this is the sequence detector circuit we have to find how this should be. If you give X input something, according to that we have to get Z. Suppose we will take one example 0 1 0 1. So first 0, anyway our sequence Z is 0 because it is not a term. Because 0 1 0 1 is full, after the 4 bit we are getting 1. First 0 1 we are not getting, so 0 0 0 and then 1 means we are getting 0 1 0 1 already there, so sequence is 1. If you give the similar way something extra number 0 0 1 0, so what happens in this case, it will not consider this 4 bit because here after 4 input it has to be reset. So we are not considering after this. We have to start from new 0 here. So the new 0 is anyway not present. So 0. Again we have to consider this 0 0 0. Then 0 0 1 is not there. And 0 0 1 0 is not equal to our sequence. So it is 0. Like that we will get the output Z given values. The thing you have to remember is there is a 2 sequence possible to get the output and every 4 bit it is become a reset. So we can move on the step 1 state diagram. So in this state diagram we can make before that state table. How can we make each state when X input is 0 and once how it change. Suppose first go to the state part. First we can take state is S0. Previously we have taken S0. You remember that the sequence is 0101 and 1001. So we will call this S0 is reset because after 4 bit whatever the thing happens it has to come reset. That means previous all bit it has to vanish and new number has to be started. And you can take S1 either from the first sequence or second sequence. So first sequence it is 0, so take 0 value. Similar way we can go for S2 and S2 sequence is the second portion, it is 1, so we will go for 1. And S3 if you go with, here you have to take 2 number from each part, 0 1 and 1 0. So we can call like this 0 1 or 1 0. So both the state possible in the S3. Similar way if you go for S4, again 2 state possible, that is nothing but 1 0 0 and 0 1 0. So 0 1 0 or 1 0 0. So this is how the state diagram can be written. Now there is a possibility of X value. In the S0 again X is we can give 0 1 and S1 also we can give it and S2 also we can give it and S3 also we can give it and S4 also we can give it. So from this what is next state we have to discuss. When S is 0, that is reset, and nothing we have, so in this state the reset state whatever number we are given as a zeros or ones, depending upon that one it will change. So S0 is 0 here, 0 state is S1, so it is going for the S1, and the next state is 1, 1 is nothing but S2, so it is state is S2. Similar way, now go for the S1, there is a 2 possibility, one is 0 given input X, so 0 0, 0 0 is not there in any state, go for individual 0, it is there in S1 only. Now listen carefully, if it is going to S1 only, what happens? The issue is here it has to, for input it has to become reset. So if you are going in the individual same state, then after 4 input we cannot make reset. So very important that we have to take one more state like that. That state is such a way that if anything is self it is coming, we have to go ignoring that portion. For that we can call as a one more state called S5. So what is this S5 means? We have to take that 2 input is received, and in this we cannot make any answer. So here 0 0 is received, 0 0 is not there in any state. So this we can call as a 2 input received and no output possible here, because 0 0 no output is possible. After some state it has to be become reset. So that state is called, we are calling as a S5. So make it that here we can call as a, this one as a S5. Now go to the state 0 and 1. Yeah, the 0 and 1 state is possible in the S3. So it is possible in S3. Similar way, go for S2. S2 is, we can make 1 0. So 1 0 is there in the S3. So it is go for the S3. And 1 1 state not there. Not there means, already I told, we cannot make as a single bit and we can cross verify, because 4 input we have to reset. For that reason, go for 2 input received but no output is possible. So it is S5. Then go for the S3 portion. Here 0 1 0. 0 1 0 is there in S4. So this state is S4. Similar way, we have 0 1 1. 0 1 1 is not there. And if you check 1 0 1 also not there. So we have to take one more state called S6. S6 we have something called 3 input. Okay, 3 input received and there is no output possible. So in this state we can directly move to the next reset state. Okay, so we will take one more state called S6 here. Similar way, S4 0 1 0. So once number come 4 state, it has to reset, because 0 1 0 0 whatever it is, after 4 every 4 input it has to reset. So we can directly call this one is S0. So all the 2 state is become S0 only. Now we can move on S5. S5 actually 2 input. So I cannot reset directly. So it has to go to the 3 input. So either 0 or 1 it is not bother, and we have to make such a way that is no output possible. So we are moving 3 input receiver, that is no output possible. So move to the S6 simply. So anyway, this S5 S6 state is dummy state. This state we are not getting output and we cannot reset in the 1 or 2 bit. We have to reset in the 4 bit only. So making delay purpose, we are taking these 2 states, S5 and S6. So anyway, S6 state 0 1 whatever it is become 4 number, because 3 input already there. One extra input if you give 4 input. So this become as a S0 state. This is how the next state we have to write. After that we will move on the Z value, that is output. When we are getting output is 1, only that condition where S4 is maps. So here 0 1 0 we have getting 0 1 0 1. So 0 1 0 1 only we are getting as a Z is high, or we can call 1 0 0 1. So these two portion, when X is 1 we are getting Z is high. All the other condition we are getting 0 only. So fill with the zeros of Z value all the other portions. So this is how we can write as a state table. From this we can do the state diagram. So step 2 we will move on the state diagram. So in this state diagram we can check out first S0. So we will take S0 and take the values. Here anyway this is reset, and if it is 0 it is going to S1. So take 0 and going to S1, and anyway Z value is 0 only. Then when it is 1, S0 is 1, it is going to the S2 state. So make it like this and make it as a S2 state. When it is 1 input and output is Z is 0 only. Similar way, go for S1. Here S1 is when 0, it is moving to the S5. So make one more state here, S5. So when it is 0, anyway Z output also 0. Similar way, S1 is 1, 1. We are moving to the S3. So we can make as a something like that. We can draw like this here, and this is something called S3. And here we can make 1 bar 0, because when S1 is 1, it is going S3, and that time Z is 0 only. And then come to the S2 value. Here S2 is 0, it is going S3. So 0 means it is going to the S3, so make it 0 here. And output anyway 0 only. Similar way, when S2 is 1, it is going to the S5, so output is 0. So make it like this, when it is 1 and output is 0. Now S1, S2 we finished. Now move on the S3. S3 has again two states, one is 0 and 1. When 0, it is going for the S4. So take S4 here when it is 0. When it is 1, it is S6. So make it 1 and it is S6. So in this both the condition S3, only 3 numbers. So Z is not possible output. So make it as a Z is 0. Now come to the S4 value. Already I told the 4 consecutive numbers over in S4. So it is going to the reset. Either 0 or 1, it is not bother of the X value. So it is moving to the S0 directly. But the stuff is 0. If it is 0, the output is 0 here. So 0 bar 0. But when input is 1, output is 1. So you have to write 1 bar 1. Only this condition Z is high. All the other condition Z is 0 only. So now move on the S5 state. S5 state either 0 or 1, it is going to the S6 only, and all the condition output is 0 only. So 0 bar 0 or 1 bar 0, it is going to the S6. And last S6 is 3 input and it has 1 input, means it becomes 4 input. So 4 input is reset. So it is going to the S6 only. So move to S6 for this one. So in this S6 condition, what we have to do, either 0, output also 0, either 1, output also 0, but it is moving to the S0. From this state diagram, we can say that there is no self in the any state, because the 4 consecutive state it has to become 0. This way we can write the state diagram. Here they are mentioned only find MEALY state, so I made only state graph. If you want to make as a particular logic diagram, then previous whatever step I have done, you have to fill the S0, S1, S2, S3 values. So you have to fill something like S0 is equal to, here S6 means we cannot do in 2 bits, so go for 3 bit. S0 make 000, S1 make 001, S2 make 010, S3 make 011, and S4 make 100, and S5 make 101, and S6 make 110. Similar way, the S7 is not there, so 111 condition make don't care. So this you have to fill with this table. Wherever S0 is there, fill triple zeros. Wherever S1 is there, 001. Similar way you can fill it. After filling this next state, you are getting as a 2 things here. One is QB plus and QA plus. So whatever value got as a QB plus QA plus, and you have to take one more called QC plus, because it is 3 bit. So each bit, whichever one, that state you have to take and make the K-map and simplify that one, you will get the logic diagram. This way you can do the, if they ask for the logic diagram. I will finish only this because of in the example given only state graph. So I finished with the state graph and I will end only this position. If you interested, you can go with these portions also and do the state table and truth table and K-map and simplification of K-map. After that you can do the logic diagram possible.